First example is a simple truss just for demonstration. We have a 2-panel truss, each panel 3 meters and a height 3 meters. The supports are at A and B, A hinge and B roller. Other joints are noted by letters. A force of 4 tons is applied at each joint of the upper chord of the truss. We have our reaction, 2 reactions at A because it is a hinge, and 1 reaction at B because it is a roller. Taking sigma moments about A equals 0, we have 4 tons multiplied by the arm 3 and 4 tons at F multiplied by the arm 6 meters until we reach A. The 4 tons rotate clockwise about A, and we assume the sign to be a positive sign. Since YB rotates in the opposite sense about A, counterclockwise, we assume the sign to be negative, and YB is multiplied by 6 meters the arm until we reach A. This gives YB equals 6 tons and is plotted on our diagram. Sigma forces in the Y direction equals 0. We simply add all vertical forces. YA and YB are heading upwards, and therefore they have the same sign, assumed to be a positive sign, and 3 forces each of 4 tons heading in the opposite direction and taking a negative sign. These are minus 4 by 3 appearing in the equation. This gives YA 6 tons and is plotted on our diagram. Taking sigma forces in the x direction equals 0, this gives XA equals 0 and is plotted on our diagram. Now we are ready to compute the internal forces. First, we use the joint method. All members are assumed to have positive internal forces or tension forces, and therefore all internal forces drawn in red are drawn coming out of the joints. So if we take DC for an example, the force at D out of the joint, the force at C coming out of the joint, and as explained before, DC has a tension force. Joint A, we simply take the joint A here and we extract it outside the drawing to be clear. Joint A has the reactions XA and YA and has the internal forces for the 2 members AD and AC as is seen now. We apply for the joint methods only 2 equations. Sigma forces in the x direction equals 0 and sigma forces in the y direction equals 0. In our example at A, we have sigma forces in the y direction equals 0. In the y direction, we have FAD internal force shown in red and the 6-ton reaction shown in green. This gives FAD equals minus 6 tons, which means it is a compression member, as we assumed the tension force to be a wrong assumption. And we plot the force on our diagram. Taking sigma forces in the x direction equals 0, we have the green 0 tons and the internal force FAC, which gives that FAC equals 0 tons from equilibrium and is plotted on our diagram here. Now we have another joint D. We extracted outside with all external and internal forces. we have the external force 4 tons applied on the joint and the internal forces of the three members connected to the joint D. So FDC can be analyzed in a horizontal component and a vertical component. Note that FDC or the member DC makes an angle 45 with the horizontal. So we have a horizontal component FDC cosine, the angle, and a vertical component FDC sine, the angle 45 degrees. Taking sigma forces in the y direction, we have the 4 tons FDA previously computed to be minus 6 tons and the only unknown to be FDC. We substitute for FDA by its value and we respect the sign, the negative sign here. So we substitute by minus 6 tons and we are left with the only unknown FDC to be 2.82 tons. As the result is positive, this means that we assumed correctly the tension force. And the force is plotted on our diagram. Sigma forces in the x direction equals 0. Now we have DC computed and the only unknown DE. This gives DE minus 2 tons and is plotted on our diagram here, a compression force. Another joint is joint E. We extract our joint E outside with all external and internal forces connected to it. Sigma forces in the y direction equals 0, gives FEC to be minus 4 tons and is plotted on our diagram. Since the sign here is a negative sign, this means that the tension force assumed in CE was a wrong assumption and the true force is a compression force. The beam is symmetric about EC and therefore all the internal forces in the members right to EC are exactly equal in magnitude and sign to the internal forces in the members plotted left to EC. And therefore, using the joint method, we computed all internal forces